Hello everyone. So I want to share my implementations of 4-bit computer with sign operations. So first here we have some RC architecture. First, if is the operation to determines what we want to do. There are four operations: add, subtract, or and multiply. And for the LF control, we have load and then fetch A or the input A, and then fetch B or the input B, and switching the operations, which means we are doing the operations that define in this operations. So the idea is, okay, maybe later on I will do the presentations, but I want to explain the architecture first. In the CPU, we have some ALU. Wait, okay, ALU. This is the simple ALU or arithmetic logic unit. There are two inputs, A and B, with the size of 4-bit each, and then this select, like the select parameter. There are adder, subtractor, or and multiplier, and we're going to the multiplexer, like switch, then determines if it's overflow or not, or it will give us output and the carry from the operations. Most likely it's like multiplication. And then we have the input-output unit. It's just a simple one. So we have two inputs, give it to the multiplexer, and we'll represent it by data. And there are some enable address, which means, yeah, like this. And the output, I use a 7-segment display. So there is input, then we'll map right here, and each of the A, B, C, D, F, G will maps to the 7 segments. So the 7-segment structure is like this, right here. So there are D, C, B, A. There are many gates. Then this is the A, this is the B, this is C, D, E, F, G. So we are using this architecture to make the 7 segments. So uh, wait, where is it? Okay, here and the low level will look like this. Okay, there are A until G. Okay, and there's a memory which save in 8-bit, and the first 3 bit or the most significant bit will be going to the decode, and the rest will into the 32 blocks, like 32 times 4 blocks. And if we look closely to these blocks, or in here, it's same as before, but the address is only like 5 of them. So we are taking 3, the rest is 5, and then we are doing the same operations here, and we'll into the 4 times 4 or the 4 blocks. If we see, it will reduce again. 5 subtract by 3 is 2, so we have 2 here. We decode again and we'll go into the BC, and for the BC implementation it's just like this. So there are single input, and the clock will be redirected to the AND gates, and then yeah, we'll showing the output. So that's all for the architectures. I will explain the main algorithm of the computer right here. Okay, this is the main. So suppose we have A and B going to the input block here, and there's like enable load B, and the left, not left, like the LF blocks to determines what we will do, like the operations, and then it will save in the memory. Depends on the whether it's read or write. So the data A and B will be saved in the memory and will be saved in the data A and data B to be operated. So here like it ready to be operated, and the data A and data B will go into the ALU or the arithmetic logic unit based on the opcode chosen here, like here. After in the ALU, we are outputting the output here and yeah, insert it to the 7 segment display. Or if there are multiplication carry out, we insert it right here. So here's the demo of the program. Wait, suppose, oh yeah, notes. I used two complements input right here, but the 7 segment display is reading the unsigned one. So it will take choose complement input and operations, but the output will be read as unsigned. So I think if there are any negative numbers, it will display differently. I just want to clarify something. So we just do simple calculations. For example, okay, first we have to ticks enabled and we have to reset the simulations first. Suppose I want to do 2 plus 3. So 2 in the 2's complement is right here, 0010, and the 3 is going to be 0011. After that, we power up the computer and then load the value, like here. Load the value right here. And then we check whether the A and B is safe or not in the memory. We can just click this once, 10, okay. The A is 2, like this instruction, and it will 3, of course. Oh, wait, why it's not clicking? Okay, 3. And the results is 5. The expected result is 5. So yeah, we get the 0 carry and 5 as a result. Okay, it works. So we are going to do subtraction, a simple one. For example, I have, wait, let me think. For example, I have 6, which is 0110, and then I have 4. Uh, 4 is right here. Okay, we can power up, load the value, and then check the LF. So yeah, it's 6, then 4. Then the expected output is 10. But the 7 segment display will display in decimal terms. So 10 in decimal terms is A. So we check. Yeah, it outputs 0A, which means 10. Oh, I want to do subtraction. Sorry. This is addition. So sorry. I've wrong and the operation. So we're going to load first. We do subtraction like here, 0, 1. Then load the value first. The expected value will be 2, yeah. As the expected value will be 4, okay. 6, 2, then 4, okay. It works correctly. And then what if we want to do like uh, plus 6 add by -2. So we have +6, which is, wait, let me reset first. +6 is 0, 1, 1, 0, and then oh, what do I want to? Oh, -2. -2 and the 2's complement are 1, 1, 1, 0. Okay. I want to do like power. Okay. Just 0, 1. Oh, sorry. We'll do add again. Uh, Load the value. So we got 6 and then -2. The result will be 4, but we'll check. Wait. Okay, 4. It gets the result. And what else again? 3 and 5 plus. Okay. 3 is 0, 0, 1, 1, and -5 is 1, 0, 1, 1. I want to add it, so we load the value first, right here, then check whether it's load or not. Okay, 3 and the -5. Why it one? Oh, sorry, wrong number. -2. -2 is E. Yeah, it will result in -2, which is E, because I do +3 plus -5, which is -2. But -2 in the unsigned is 1, 1, 1, 0. But if we represent it in the 7-segment display, it will output E. So yeah, it works. We reset the simulation. Now the multiplications. Suppose I have 2 here and I have 3 here. Then power up, load the value, and do some multiplications. Why it won't budge? Okay, we load the value again. Okay, 2, 3, and what if I want 6? Okay, the multiplications is work. What if I want to do like 5 times 3? So 5 is 5 is here, 4, yeah. 5 times 3 equals to this. I want to load it first. Okay, load. Okay, first 3 times 5 equals to 15 in the unsigned is F. So it will output F. But what if I want to do like uh, multiplications of, for example, -2 times -2, so it will output 4, right? It -2 times -2, yeah. -2 is 1, 1, 1, 0, and 1, 1, 1, 0. And then I need to do multiplications. 1, 2, Okay, let the value minus 2 times minus 2 equals to 4 right here. But we have C here, I think because of the overflow, but we get 4 right here for the result. So I think there's a carry somewhere, like there's a little bug, but it works. So yeah, I think that's all for the presentation. Thank you and see you in the next time.